Hi everyone, in this video I'll be talking about Cartesian coordinates versus polar coordinates. So on the screen already you can see we've got a Cartesian plane which has an x-axis and a y-axis. When we draw points on our Cartesian plane, for example, if we plot the point here, we've gone across 3 units on the x-axis and 1 on the y-axis, so this point is 3, 1. So we always write the x before the y, and you can remember that because that's how we talk about the alphabet. X goes before y. When we move around our Cartesian plane, sometimes we get some negative numbers as well. So if we plotted the point down here, we're 2 units across in x, and we are minus 3 units in y. The other thing we can do very easily with Cartesian plane is we can plot lines. So for example, if we had the line going through here, let's say we've got this lovely line. Here we have a y-intercept of 2, which you can see here, and we have a gradient of 1. So if we wanted to, we could write the formula for this line as y equals mx plus c, where m is our gradient and c is our y-intercept. So in this case, we'd have y equals x plus 2, because we have a gradient of 1, and 1x is just x, and we had a y-intercept of 2. So there's some nice easy things we can do on a Cartesian plane. If, however, we decided to plot something a little bit more complicated like a circle, sometimes it's easier if we shift to polar coordinates. So here's an example of our polar coordinate system. Our polar coordinate system, instead of using x and y, here we need to use r and theta. So r is the distance from the center, okay, or distance from the origin. So you can see on this particular plane we have different circles. So we have a circle at radius r equals 1, and then we have a circle at r equals 2, and another at r equals 3. So we've got those circles, and you can tell also we've got these lovely lines around the outside that help remind us where the different angles are. So those angles are the theta values. For example, if we wanted to plot a point over here, we would say that r equals 2 and theta equals 120 degrees. Now, I particularly chose a polar coordinate system here that is using degrees, because in MZB 102 we will be using degrees. So that's one point, and we can just move around the circle and place different points here. For example, if we put the point here, we only actually need to specify the radius, r equals 0, because it holds for any value of theta. If we wanted to plot a circle, like I said, a circle is going to be much easier on our polar coordinate system. Let's say we wanted to plot the circle here. That's just r equals 1. Because you can tell we need to have every value of theta around the outside of that circle so that we can trace that line. And if you're having trouble with that, it might be worth having a look back to the section on locus so we can remember about how circles work and how they form. Okay, they're the basic difference between Cartesian and polar coordinates. In the next couple of videos, we'll talk about how you can convert between those two coordinate systems. Hope that helps.